Welcome back to the new video and new concept. Today we are discussing the method of separation of variables. This is again one of the method. As we earlier discussed, a non-homogeneous partial differential equation with direct integration method. First method we have discussed. Second method is a homogeneous partial differential equation with respect to derivative with respect to one independent variable. Second one. Third one is we are discussed already the Lagrange's PDE. The fourth one is we are having method of separation of variables, and this is very easy. We are converting the partial differential equation into two ordinary differential equation. For example, if it is first order, you will get two first order ordinary differential equation. If it is a second order, you will get two second order partial that is ordinary differential equation, which we have already solved in the previous class. So now look at this example carefully, and it is very easy one. In this example, first or let here u is the dependent variable, x and y are the independent variable. We write u is equal to x, capital X into capital Y, or you can also write, where capital X is the function of small x and capital Y is the function of small y, is the solution. Is the solution of the given PDE by using method of separation of variables. Our aim is to extract or find the value of capital X and capital Y and substitute in this equation. You will get a solution. So now let us substitute u is equal to xy in the above equation. What will happen? Can you please pronounce? Second step, substitute u is equal to xy in the above equation. What will happen? Dou times of capital X into capital Y divided by dou x plus dou by dou y of capital X into capital Y is equal to 2 times of x plus y into u is capital X into capital Y. Isn't it? Okay, I am going step by step. Just remember, in the first step we have u is equal to x into y is the solution. In the second step I am substituting that solution in the given equation. Okay, now what you need to concentrate is, here capital Y is function of y, as you know the principle of partial differentiation, isn't it? So here it is with respect to x, y is treated as a constant, isn't it? Here you have capital X and capital Y. Capital X is a function of small x, capital Y is depending on small y. Means when you differentiate with respect to x, y becomes a constant. So we are taking y outside. This is y into, it will become dou capital X by dou small x. Here with respect to y, we will take capital X outside. It will become dou y divided by dou small y is equal to 2 times of x plus y into, this is capital X into capital Y. And remember, whenever this derivative with respect to one independent variable becomes, it is an ordinary. Capital Y into this dou becomes d capital X divided by d small x plus capital X into d capital Y divided by d small y is equal to 2 times of x plus y into capital X into capital Y. So this is the procedure, because dou capital X into dou x becomes an ordinary. This is the procedure by using the method of separation of variables. So what is our next step is, we need to express in such a way that left side is the function of x, right side is the function of y only. How to express? Left side andre edagade function of x barabeku, balagade function of y baranga ನಾವು express ಮಾಡಬೇಕು. ಅದನ್ನು ಬರಬೇಕಾದ್ರೆ ಏನು ಮಾಡಬೇಕಂದ್ರೆ, next step what we are doing is divide throughout by capital XY. You can divide both sides by capital X into capital Y, and observe what will happen. You can divide it by capital X into capital Y here. This is dx by dy, so dx. This is capital X divided by capital X into capital Y into d capital Y divided by d small y is equal to 2 times of x plus y into capital X into capital Y divided by capital X into capital Y. I have divided both sides by capital X into capital Y. Right side capital X into capital Y get cancelled. Here y and y get cancelled. Capital X get cancelled. So why we have done? You will come to know that is 1 by capital X into d capital X by d small x plus here 1 by y into d capital Y divided by d small y is equal to, this is 2x plus 2y. I have written separately. And further, in the next step, just look at, I will write this step as it is, 1 by capital X into d capital X divided by d small x. I will bring this 2x to left side. It will become minus 2x. Okay? And this total y into right side, it will become minus of 1 by y into d capital Y divided by d small y plus 2y. And you can observe very carefully that left side is only function of x. Only x terms ಅಷ್ಟೇ ಇದಾವೆ ನೋಡಿ, ಚೆಕ್ ಮಾಡ್ಬೋದು ನೀವೆಲ್ಲ, ಹೌದಾ ಇಲ್ಲ? ಇಲ್ಲಿ ಕ್ಯಾಪಿಟಲ್ ಎಕ್ಸ್ ಸ್ಮಾಲ್ ಎಕ್ಸ್ ಅಷ್ಟೇ ಇದೆ, ರೈಟ್ ಸೈಡಲ್ಲಿ ಬರೀ y ಟರ್ಮ್ಸ್ ಇದೆ. ಸೊ ಲೆಫ್ಟ್ ಸೈಡ್ ಈಸ್ ಎ ಫಂಕ್ಷನ್ ಆಫ್ ಎಕ್ಸ್, ರೈಟ್ ಸೈಡ್ ಈಸ್ ಎ function of y. So next step is we need to equate. We need to equate both sides to some common constant k. If you equate both sides with common constant k, it will become 1 by capital X into d capital X divided by d small x minus 2x is equal to k. Okay, next right side minus 1 by y, yes, dy by d small y plus 2y is equal to some k. Okay, so now what about these two represent? These two are called first order differential equations. First order differential equation means you have dx by d small x, means here capital X is the dependent variable, small x is the independent variable, here capital Y is the dependent variable and small y is the independent variable. Now how do you express this as? 1 by capital X into d capital X divided by d small x is equal to minus 2x goes to right side, it will become plus 2x plus k. Here how do you express? I am multiplying both sides by minus sign. What will happen? 1 by y, okay, d capital Y. Is it a small y or capital Y? Capital Y. dy by d small y. When I multiply minus sign here, this will become plus, this will become minus, right? Minus goes to right side. Plus 2y, either you can write plus k or minus k, doesn't matter because it's after all a constant, doesn't matter. So further just look at, we are using the variable separable method, as you know in the previous class also. What is variable separable method? I will write once again, just look at p dx plus q dy is equal to 0. Dx coefficient should be function of x, dy should be coefficient of function of y only. Here d capital X coefficient should be function of capital only, isn't it? And dx coefficient should be function of small x. To achieve that, I am cross multiplying this. This is 1 by capital X into d capital X. This is 2x plus k. You can cross multiply dx and observe dx coefficient is function of small x. If it is a constant, we will neglect it. and dx coefficient is 1 by capital X. Similarly here also, please tell me, 1 by capital Y into d capital Y is equal to, this is 2I minus k into d small y. Now the variables are separated, okay, isn't it? Now you can write, now the variables are separated. What is the next step? We need to integrate. And integrate, what will happen? Integration of 1 by capital X into d capital X, integration of 2x plus k into d small x plus some constant k, or you can call it as a C1. Next, here an integration, this is 1 by y into d capital Y is equal to integration of 2y minus k into dy plus, you can write C2. This is C1 and C2. Now an integration of 1 by x. What is the integration of 1 by x? Log of capital X is equal to, this is, look at, integration of 2x is x square, because integration of x is x square by 2, 2 and 2 get cancelled. This k becomes kx plus C1. Similarly, the another one is integration of 1 by y is log capital Y is equal to, this is y square minus ky plus C2. Usually it is the base E. It is in logarithm form. You know, you people already aware of logarithm to exponential form, isn't it? I will tell you, just look at, when you have e raised to, or when you have 2 raised to 8 is equal to how much, or 2 raised to 3 is equal to how much? 8, isn't it? 2 raised to 3 is equal to 8. So then what is the logarithm form of this? Logarithm form is log of 8 base 2 is equal to 3. Log of 8 base 2 is equal to 3. This is called base, this is the power. The power becomes right side, this value becomes here. This is called logarithm form and this is called exponential form. Since it is in logarithm form, it will become capital X is equal to, E will become rise, e power x square plus kx plus C1. Here y is equal to e raised to y square minus ky plus C2. Okay, so when you got a capital X and capital Y, then what is the solution? Therefore, solution is u is equal to capital X into capital Y. What is capital X? E power x square plus kx. Shall I write this is e raised to C1? You can make it separate also. When base are same, you can add the powers. When the power is sum of 2 or 3 terms, you can able to express back. So therefore, into this is e power y square minus ky into what? E raised to, this is C1, this is e raised to C2. Okay, so finally, this is, how do you write this as? The power. You can write it as e power, when base are same, powers are added again, x square plus y square plus in these two, k is common, you can write x minus y, e raised to C1 is constant, e raised to C2 is constant, the product of two constant is again constant, you can write just C only for our reference, or which is C times of e power x square plus y square plus k into x minus y is equal to u is the solution. If you have any doubt regarding this explanation, you feel free to ask. Okay, just you can write. If you find any difficulties, you can ask the question. Thank you.